Hello and welcome to MyTechFun. In this episode I am doing my second upgrade on this Ender3 V2, and this time it is the dual Z-axis. And this kit was sent to me by Banggood for a review. But first let's see what is the problem with the single screw lid. This is the Ender3 from the back side, and it has only one screw lid here, and if I rotate it over this nut, it will lift or move the whole Z-axis gently here to this alloy extrusion. But it is supported only on one side, and I can measure on this side that it has more than 0.1 millimeter of playing here on this side. On this side it is 0.02 millimeters maybe, because it's held here by the screw lid. In most cases that's not a problem, because when we are leveling the bed we will make it actually parallel with the moving path of the nozzle. So if this is a little bit under the angle, so the bed will also be leveled on that way. The problem may appear if you have some, I don't know, square parts, still horizontal and vertical, and maybe that will be under a small angle, that will not be accurately 90 degrees. But that's a smaller problem, you will probably never notice that. The biggest problem is for me, I am planning several upgrades here on this hot end and extruder, and I will add a lot of weight to this hot end. So when it's in this position it will maybe too much weight, and this means that I have to reduce the printing speed, because on higher speed it will have more moment of inertia, and I will have more ghosting or something like that. So very practical and quite cheap upgrade is to have another screw lid on this side to support this alloy extrusion from both sides. And of course it's logical, it's much easier to support some bridge holding on two sides compared only on one side. And probably the heaviest thing which I will mount here where the hot end is the direct drive extruder. This means the stepper motor will move from here to here, so it will directly be on this alloy extrusion. So let's see what's in the box. Manual with the parts, very nice packaging, the lead screw, which should be very straight, okay, stepper motor and the shaft coupler, cables for stepper motor, so probably one goes in the motherboard and these two goes to the stepper motors of the Z-axis, some bolts and nuts. This is the holder on the other side, this will hold this nut. I'm not sure, I believe this is a holder for the stepper motor, position holder for the lead screws. So all I have to do is to mount all these here, similar to this lead screw. I will leave the electronic for the end, so I will have this cable here now for now. Let's see first the mechanics. So here we have the stepper motor. Very big help is this Z-axis, which is already mounted on the 3D printer. So in same position. So this is the stepper motor. Here goes the holder, which will be locked with these screws. We have the shaft coupler. This side goes on the stepper motor, and the lead screw on the other side. And this goes on the x-axis extrusion, hollow extrusion. I think this side up. And I believe it's a little bit optional. So here in this tutorial, it's manual. It says T-bar fixator A and B. So this theoretically goes here on the top. It should rotate freely around it and a little bit move. I hope it's visible on camera. Theoretically this should only protect this screw if you hold it here, so you don't deform it or something like that. And all I have to do is to mount this mechanics and stepper motor on this side here. And the big help is this side, which is already mounted on this 3D printer. It is always helpful to leave the bolts and the nuts in the packaging, because here I can see their dimensions exactly. Okay, I'll try to use this expression. This is this list of parts. So the first step is the stepper motor and the Z-axis motor mounting seat. And of course, big help is here the existing stepper motor. So this is on the back side and this goes on the front. Now what is tricky that these two surfaces should be aligned. I noticed that even these brackets which are pre-assembled was not in aligned, and I had some problems that this lead screw was under the angle. These two surfaces should be aligned, and easiest way to do this actually is to rotate the stepper motor in this way, and then these surfaces are in the same plane, and then I can mount it with the two screws here. So I need these M3 by 16mm bolts, and I will mount them here. This surface has to be aligned. For the next step, I will mount the stepper motor to its position, and for this I will need two M4 T-nuts and M4 by 14 countersunk bolts. Place the bolts inside and start with the T-nuts on the other side. It has to be in this position. I hope it's visible. And in this position I can insert it into slots, and when I'm rotating the bolts, these nuts will rotate and lock into place. Make sure the T-nuts rotate at 90 degrees so they lock in this slot. In the next step I am mounting this shaft coupling. So this is probably 5mm and this is 8mm. So this one goes on the stepper motor. Now it doesn't go completely down because I don't want it. Let me show you. I hope it's visible, the shaft here. It doesn't have to go completely down. Approximately here, because on the upper side I will have that 8mm screw. So I lift it up until I can see the shaft of the stepper motor is in its own half, and I can tighten the lower screw only. And tighten this until you cannot move up or down this coupler. Double check that the shaft is not in the half where the screw will go inside. Now I have to mount this Z-axis passive block here with this screw nut here, but we didn't get any wheels, so I have to use these 3 wheels and bolts from the original version. Move the X to the opposite side completely, so it will reduce the weight here, because we will remove now these wheels. These screws I can remove with the open end wrench from one side and the Allen key from the other side. But as you can see, these bolts are a little bit too short, because this will go here. That's why we get this, what is this, 5 by 40 bolts. They are longer, so they can hold this passive block on the other side. So these are too short, I have to replace them with these ones. But try to group in one place, because then you will not mix with the other parts. So this last one is the adjusting wheel with this X-center here for the setting. Okay, so this is the position for this passive block, but these longer bolts can be inserted from this side very easily. But unfortunately, this bolt here, the head of this bolt is in this slot below this passive block. and I cannot replace it so easily. This means I have to detach somehow the alloy extrusion from the passive block to insert this longer screw. We add this washer to the new bolt. I will not tight yet. Ring, wheel, and ring. So if you're not sure, you can always check the other side. So this is the stepper motor for X-axis. Here is the bolt, the ring, wheel, ring, and the screw nut on the other side. And these are those extra rings we got now in the package. And for last adjusting wheel, you can get help here on the opposite side. And after tightening these three nuts, then you can check the adjusting nut for this third wheel. It should not rotate freely, you cannot rotate it by hand. Now I can insert this lead screw. And it should go down completely here to this coupling. Now it doesn't go. Okay, so it doesn't go inside for some reason easily. I don't know, should I cut from the video? This might suffering, but I want to show you if you have similar problems. So I will detach from the stepper motor. And first I will mount the coupling on the shaft. And it goes completely until it hits here the end of this step hole. Okay, it looks like this shaft and screw lid was under a small angle, so I loosed these bolts here, and then I can little bit move this stepper motor. I hope you saw that now it sits completely on the shaft, the coupler. And now I can tighten back these bolts. Now one more time check if this lead screw is aligned with this alloy extrusion here. If not, you can again loose these two bolts, and here from the other side, and adjust a little bit left or right this stepper motor. Make sure that this is parallel with this alloy extrusion. One more time, make sure that these two bolts are tight. Approximately check if this x-axis is horizontal position, just approximately for now, and try to move it to the upper, bottom and top position to see everything is okay with this distance. So these two screw leads should be very parallel with each other, but you can check that they are parallel with this alloy extrusion, and if yes, then they should be parallel with each other too. Now the last thing from the mechanics is this T-bar fixator, and I have two of these. In original version, as you can see, it's not here. Is it visible on camera? Yes. Okay, so what we have here, I'm not sure if it's visible on camera, is this ball bearing, and it should move a little freely here. So it just approximately locks the position of this screw. I will place it here so you can see. It should move freely a little bit. So it just prevents that if you grab it like here, that it will not bend if you grab it very strongly or something like that. Let's see what's inside quickly. I believe there's some kind of ball bearing inside. Yes, it's just a ball bearing which moves, well, almost freely, not much, only maybe 1 millimeter or even less. Okay, it's back, and just to check, is it still moving freely inside the ball bearing. Then place the tin nuts on the other side in this position. I hope it's visible on camera. It's much easier to mount this before the screw lid is here, but it's here. I hope I can bend it just a little bit. I will move the axis down. And when it's down, I hope I can move, you can see, bend this lid screw so I can insert these tin nuts into slot. Yes, they are in, and I can tighten the bolts. Okay, it's not tight completely yet because I want some freedom in this axis. Move the Z-axis up. And the same procedure is on the other side. So I have to move the Z-axis completely down. I will remove this plastic cover. Insert 2 bolts. And if the Z-axis is down, then I can move this, bend this a little bit, this lead screw, so I can insert the nuts into slot. And it looks like again it will stand out a little bit to the side, so I'm not sure if I will place back the plastic covers. Now I can tighten the bolts. Let's see if I can place back this cover. Oh yes, okay. And the mechanics is ready. I used all parts from here except the cables. Unfortunately, manually they don't mention at all how should I connect these cables. And unfortunately, I couldn't even find any manual on the internet or some video, but at least you will now have this one. So in theory the wiring is easy. So this side of the cable goes to the motherboard where the other side of this cable is. They're marked, labeled, you can see the Z. And the other side, it's split into two directions. So these two connectors goes into the one and the other stepper motors. The only thing I don't know so far, how to find the path where to move, but I will try to follow this cable to the motherboard. Now this is the Z-axis cable, and it goes down here. Now unfortunately I'm sure that through this small hole I cannot push the end of this cable, but maybe I can remove this cover. I can see, and here you can see screw for this cover, so this one and that one inside. This is the other screw. Never move too quickly these, because stepper motor may produce the electric power in that case, and that if you move too fast, that may be too much. Did I mention that everything is much harder to do it in front of camera? Now I can lift it, so I will have enough space here to insert the end of the cable. doesn't touch the desk. So let's see what's below. I hope it will be visible on camera. So this is the this cable goes to the extruder stepper motor, and this one here, you can see the small Z. This goes to the Z-axis stepper motor, so I have to replace this with a new cable. And if you follow this cable, this is the one, and it goes up here. And I just removed that screw, so I hope I can press the cable through that gap. Okay. Z-axis, and it goes up through that gap. Okay, through the same gap. And it's in. Okay, it's snapping. And one thing to check is this fan rotating freely, just in case. And okay, nothing blocks it, so everything is okay. So here is the cable. My previous version goes on inside to the extruder, but I think this one is longer, so I will place it outside. Just in case, because if inside it bends, it may touch the heated bed, and I don't want to damage these wires. And on this part I cannot place this protection, because here it splits to two. So this shorter cable goes on this stepper motor. And the other one goes to the other side, but I will place this cable protector on it. And now the signal will be sent now, the same signal, into two stepper motors, so theoretically they should move exactly in the same moment and in the same direction. Now everything is prepared, the mechanics and the wiring, but before I turn it on and test the Z-axis moving, I want to make sure that this is horizontal. Now, so I need some reference, but I will not use the printing bed as a reference, because I'm not sure that this is horizontal. Okay, so I will move up until it touches the top hollow extrusion. Okay, and the other side. And now let's give it the power. Prepare, move, Z-axis. First start with a small value. Okay. Let's see the homing. Now we add some lubricant here. level the bed and let's do some printing. I hope Prusa lubricant is compatible with Creality and it will not explode or something. Okay, so these are my first test prints, and as I predicted, there is not significant difference in printing quality at the first look on default speed. Maybe it would be more noticeable difference if I would print on high speed, but I didn't test that yet. But one thing I noticed, and that's why I printed these 90-degree angle objects. I'd already mentioned it earlier that if the single Z-axis screw is not completely horizontal but under small angle, you will level the bed, but that bed will not be exactly 90 degrees with the Z-axis. And so this one is printed on single screw on Z-axis, and I hope it will be visible on the camera. So it touched the top, and you should see bigger gap on the bottom. So it's not exactly 90-degree angle. And this one was printed with the dual Z-axis. And this is now almost perfect 90-degree angle. So the final conclusions. Do you need a dual Z-axis upgrade on your Ender3 V2? If you are printing mostly figures or smaller technical parts with the default speed, then probably not. But if you want to print some larger technical parts, or you want to experiment with higher speeds, then definitely this is very useful upgrade. And especially if you plan to upgrade anything to add more weight to the hot end. For example, I am planning to add a direct drive, and in that case definitely this is one of the must upgrade on this Ender3 V2. One thing you have to pay attention, that if the stepper motors are disabled, in that case theoretically these screws could rotate independently from each other. That's why it is important to tie these wheels as you would do normally with a single screw. But at the beginning, pay more attention to the bed leveling. My solution for this is the BL Touch Auto Bed Leveling Sensor. This will be one of my next upgrades on this Ender3. And if you decide to buy this upgrade from the Banggood, I place the affiliate links down in the description. It doesn't cost you more, but it will help to me and my channel. And if you want to support me, you can use that affiliate link. But probably my next video will be upgrading the all-metal hot end by Micro Swiss. And I hope you will follow me to that video too. Until that, thank you for watching and happy printing!